Hi dear, today we'll see the new chapter, chapter 4, carbon and its compounds, okay, chemistry, okay. So, carbon and its compound. Carbon is a versatile element, okay, versatile elements. That's why we are going to learn in a separate chapter, okay. So, it plays a vital role in our life and also in this universe, in the earth, right? Because most of the things that we use are whatever maybe our living things, our structure, all are made up of carbon based things, okay. Most of the living things things we used are carbon based, and also all the living things, our structures, etc., are all carbon compounds, okay. So that's why we call it as a versatile element, okay. But if you see the percentage of carbon in the earth crust, it is very low, of the range 0.02 percentage, that too available in the form of carbonates, bicarbonates, coal and petroleum, okay. In the earth crust, it is available in the form of carbonates, bicarbonates, coal and petroleum, about only 0.02 percentage, okay. And also in air, air also it is of very low percentage of carbon in air is very low, as 0.03 percentage, okay. So but carbon is a versatile thing, but it is available only in low percentage in earth crust as well as in air. But in spite of this, a small amount of carbon available in the nature, the importance of carbon seems to be immense, okay. So carbon is very, very important. So we are going to study about the properties of the compounds and its compounds, okay. Why it is so important, okay. Okay. In last class we have studied about the ionic compounds. Do you remember ionic compounds? That means the metals will lose electrons and the non-metals will gain electrons, right? So these two this will form a compound, right? But that is charged one, okay. That is Na plus Cl minus, okay. Likewise it will be formed because Na has one electron and Cl needs one electron, so Na will lose electron and it is gained by the Cl, right? So Na plus and Cl minus, right? It will be like that, okay. But in case of carbon, if we take a carbon, the atomic number of carbon is 6, right? So this K shell contains 2 electrons and the L shell contains remaining 4 electrons, right? Remaining 4 electrons, right? So it is for this carbon compound, it is very difficult for it to lose, either it has to lose 4 electrons or it has to gain 4 electrons to form an octet or stable one, right? Okay, so if it lose 4 electrons means this becomes carbon, lose electrons means then your protons will be 6 here and only the electrons will be 2, okay. And also it is very difficult to lose 4 electrons. Large amount of energy is required to lose 4 electrons, okay. So if in case if it gain 4 more electrons means it is very difficult to for the nucleus to hold 6 protons plus extra 4 electrons are arrived, right? So it becomes 10 electrons, okay. It is very difficult for the nucleus to hold 6 protons, and for the 6 protons, for that 6 protons it contains 10 electrons, right? So it is difficult for the nucleus to hold that, and also if it tries to remove all the 4 electrons and become to stable means it requires a lot of energy to remove the electrons from that, okay. So to overcome this problem, whether it can gain or lose, both the things it face problem. So to overcome this problem, so it usually share the electrons between the atoms, mutual sharing, okay. It will not lose or it will not gain, but it will share of electrons. So what is meant by this covalent bond means a chemical bond formed between two atoms. It is a bond formed between two atoms by mutual sharing. Mutual means what? This atom will also share one electron. This atom will also share one electron. Okay. For example, this H requires one more electron. Cl requires one electron. Okay. Cl requires. Okay, then this one electron will be shared here and this one electron will be shared here, and so this hydrogen will take 2 electrons, and likewise chlorine will also take 1 electron. So they form a bond. Okay, a chemical bond formed between two atoms by mutual sharing of electron is called covalent bond. Okay. Where it will happen, the sharing of electrons takes place in such a way that each atom resulting molecule gets a stable electron arrangement of inert gas. Okay, for the chlorine to be stable, it requires one more electron. For the hydrogen to be stable, it requires one more electron. So for these electrons, they want to become a inert one, stable one. They then these two will combine together. Okay, to form a bond. Okay, that this only the atoms present in the outermost shell only will form a covalent bonds. The atoms share only the electrons in their outermost shell in the formation of bonds. Okay, this here, no, K shell, these two electrons will not form a bond. Okay, only the electrons present in the outermost shell will form a bond. Okay, the covalent bond is formed when both the reacting atoms need electrons to achieve the inert gas electron arrangement. If both the things required to attain the inert gas, then only it will combine. The bond will be formed. Okay. Usually it happens only in the non-metals, because non-metals only will have 5, 6 and 7 electrons in the outermost shell. Okay. So this if the 5 electrons are present in the outermost shell, then it requires 3 more electrons to form a octet rule, to form a inert gas, stable one. Okay, 6 electrons is there in the outermost shell, then it requires a 2 electrons. 7 means 1 electrons is required, right? So in the outermost shell of their atom, except for carbon and hydrogen. Carbon has 4 electrons in the outermost shell and hydrogen has 1 electron. Okay, that's why it usually acts as a electropositive as well as negative also, this hydrogen, right? We are seen in the reactivity series, right? Okay, next, so we have seen what is covalent bond. It is formed between usually in the non-metals, because both will need a need of electrons. Okay, both the things will need of electrons, so they will mutually share each other and form a bond. Okay, so there are 3 types of bond: covalent bond, single covalent bond, double covalent bond, triple covalent bond, based on the number of pairs of electron they will share, right? From each atom, one atom electron will be shared. So if they share 1 pair of electron, then it is called single covalent bond. If they share 2 pair of electrons, pair means what? 2 numbers. If it share 1 pair of electron, then it is called single covalent bond. When it pair 2 pair of electron, this is 1 pair and this is 1 pair, then it is called double covalent bond. When they share 3 pairs of electron, 3 pairs of electrons, this is 1, 2, 3, 3 pairs of electrons, then it is called triple covalent bond. Okay, we'll see some of the examples. Single covalent bond. Single covalent bond will take this hydrogen atom. Okay, hydrogen atomic number we know that 1. So the outermost shell, it contains only 1 atom. It requires, this K shell requires 1 more electron to complete, right, to become stable, right? So it readily combines with a another hydrogen atom. This hydrogen atom also need to become stable, it needs 1 more electron, right? So these two will form a bond. Okay, the single bond is this will share, and it this will combine with the electrons in this hydrogen atom and form a stable compound. Likewise, this hydrogen atom share this electron and becomes a stable one. Okay, single pair. Okay, so it is represented by a line. The single pair is represented by a line. So these hydrogens combine to form a hydrogen molecule. This is a hydrogen molecule. Likewise, chlorine. Chlorine atomic number is 17. So in the outermost shell contains 7 electrons. So it needs 1 more electron to become stable, right? Likewise, so it combines with another chlorine atom. Okay, that chlorine atom also required 1 more electron to become stable. So these two atoms combine, mutually share their electrons. So this will share this electron and this chlorine will share this electron. They combine together to form a stable one. Now this is stable and this is also stable, okay, by mutually sharing. They are not going to lose or gain, okay, they are sharing each other, okay. So this is a single pair, one single pair is represented by single line. So this is chlorine molecule, okay, chlorine atom plus chlorine atom combine together to form chlorine molecule, okay. Likewise for double bond means two pair will be shared, okay. So example is your oxygen. So in the oxygen you will have 6 electrons in the outermost shell, right. So it needs 2 more electrons to become stable, right. So it combines with another oxygen atom. It also requires 2 electrons to become stable. So these two combines to form. So now it contains 8 electrons. Now this atom contains 8 electrons. Now they have become stable and they are sharing 2 pair of electron, right. So it is represented by 2 lines like this, okay. So this is your oxygen molecule, okay. The next one is a triple covalent bond. Triple covalent bond, likewise here it will share 3 pair of electron, 3 pairs of electrons, okay. This nitrogen, it contains 5 electrons in the outermost shell, so it requires 3 more electrons, right. 3 more electrons to become stable. So it combines with another nitrogen atom to form a nitrogen molecule. So 3 pairs are sharing, so it is represented by 3 lines, okay. So we have some properties of covalent bonds. The first one is the covalent bonds are made up of molecules and not ions, okay. It is made up of molecules. It is not charged ion, either it is positive or negative, okay. It is not charged one. Since it is not a charged one, they will not conduct the electricity. They are poor conductors of electricity. Once the chemical is a charged one, partially charged one, or charged the compound, then only it conduct electricity, right. So these are not charged one, these are only molecules, okay. Covalent bonds are generally liquids or gases due to the weak force of attraction between their molecules, okay. Usually it occurs in the form of liquid or gas. Some exceptions always are there. So except glucose, urea and iodine, etc., they are all exist in solid form, okay. Covalent compounds are generally insoluble in water. Insoluble in water, indicating that they are non-polar in nature, but they are soluble in organic solvents, okay. Non-polar means here the electronegativity, they will combine with the similar electronegativity things, okay. This non-polar and all we'll study later, okay. Indicating that they are all non-polar in nature. That means they will cancel each other, right. For example, HCl means this is also H plus and Cl minus, right. It will cancel each other, right. There is no charge, right. Likewise there is no charged one, okay. If there is a partial charge in them, then only it will mix, okay. These are not charged one, okay. So covalent bonds are generally insoluble in water, indicating that they are non-polar in nature but are soluble in organic solvents, okay. Next one, and the last property of this is covalent compounds have generally low melting and boiling point, because in covalent bond molecules have strong bond within the molecule. The carbon molecule it is made up of strong bonds, but not with the but the intermolecular forces are weak. When it combined with other things, it is weak, okay. So covalent bonds are generally low melting and boiling point, because in covalent bonds molecules have strong bond within the molecule, but intermolecular forces are very weak, okay. These are some of the properties of covalent bonds. So it is not ions, it is made up of molecules. They are poor conductors of electricity. They have weak force of attraction between their molecules. So it is exists generally in liquid and gaseous form, not in the solid form. Some exceptions are there, like glucose, urea, iodine are solid form. And it is insoluble in water, but it is soluble in organic solvents. And it has low melting and low boiling point because of the weak force between the intermolecular structure, okay. Thank you.